So hang on there.
Okay.
Put on your best face and then.
Okay. Okay, we can start now. Okay, so welcome everyone online and in physical. So now we are on the 6th discussion panel, technology simulation. Okay, so can we all introduce ourselves first?
Hi, I'm Jiradej Setabundhu from PGBIM, and I'm mostly a composer with the need for high tech, but cannot attain high tech, so I usually work with the low tech only.
Hello everyone, my name is Thanapat Ogaslert. I'm the recent, the newest member of Thai City Ensemble. I'm doing the part of electronics and like sideman doing all the troubleshooting.
Hello, I'm Siu Vichichai Botong, senior here student, computer engineering. Yeah, that's my field. Hello, everyone.
Hello, my name is Nu Tavisak Kangsi. I'm a fourth-year student in KMITL, the field of mechatronic engineering.
Hello, I'm Khaimuk Siriwan Jamniela, senior in Faculty of Engineering in Mechatronics field. Same.
Yeah, and you, Karl?
Okay, my name is Karl Gerber from Munich, Germany. I'm an independent composer after have terminated my daytime job 3 years ago. So I'm a full-time composer and builder of weird music machines and so forth.
Always a good thing to do, Karl. So why don't we start now? Karl, I think we all received message from you about what you think of this technological simulation is about.
I was the only one.
Right. Well, in that defense, I tried to reply it yesterday, but maybe the message lost in hyperspace or whatever. But hey, since you start this, how about you will begin this by telling us and the audience, what do you think of technical simulation at this point? Because I'm coming from the pure music point of view, it will be almost like esoteric world to me. So thank you, Karl. Let's start that.
Oh, I'm not the engineer in this panel. Maybe the engineering youngsters will correct me. So, but let me go back in time a little bit. In 1970, when I was 16 years old, I entered a semiconductor company as an apprenticeship student, and so that was definitely the high tech at that time. There were still vacuum tube technology in record players and so forth, but we had silicon technology. And for the integrated circuit, they had simulation. So they would calculate or simulate with computers, large computers, the behavior of the electrical signals in a circuit. So, because if you have implemented in silicon, you cannot make changes. On a discrete PCB, you can make changes, but basically on a silicon monolithic circuit, you cannot make changes. So they had to do the analysis in advance, and they did it in a mathematical model. So we also call that modeling. And in the industry, till today, it is a way to solve problems and to foresee problems and prevent problems. For example, I think the Swiss simulation company, the tool is used to prevent radiation threat in power plants and so forth. And also, it's not necessarily computer technique, it can be a simulation. So the term simulation you can use for, let's say, a crash test. So you have a crash test dummy, and the crash test dummy suffers is injured, but no human is injured. But you can study the behavior and the risks coming about from a crash. So it's a replacement. And but in the film industry, you use the word mock-up. Yeah, or a treatment or something to first make a sketch and to study the behavior or the attractiveness by this sketch. So that means it's a replacement for something, a very useful thing, but it's not the real thing. So for us as artists, therefore we can say, okay, I use simulation. For example, in my real-time concept, of course, there is no notation anymore. It's bypassed, so the machine is directly coupled to a computer and will execute the commands. So no paperwork or screen notation. So it's bypassing. So it's simulating something else, but is it then the real thing? And there's so much buzzwords like virtual reality, augmented reality, quantum computing, and all these are nice buzzwords. If you want to impress journalists or so, that you should use this. But do we want this? Or I may be wrong. I may be totally wrong because I'm so old, yeah?
I think you have talked about the concept that quite similar to what I talk with the three engineering students here, the young engineer here. So they talk about using the simulation to predict something, to predict some complicated world in order to know in advance whether the model work or not. And probably likely for industry to save money as well, right? So I think that I will let pass the microphone to the engineering team and let's hear from their point of view.
Okay, I heard from Karl, and it's true that to simulate the circuit that have to see the current in the circuit and predict that it's work or not. Yeah, it's the same way that I use simulator. And another thing is, in my field in mechatronics, I used to simulate to build the prototypes by 3D printer. Yes, and when I have to print it, I have to know that how much time, how long they will finish, and how much filament, how roll of filament, plastic, yes, to build, and I will prepare the filament for it. Yeah, it's very useful for simulate before work.
And how accurate is this prediction mostly? Is it quite accurate benefit in the real world?
I think it's not 100%. It's maybe 60 or 70. But so I will multiply the safety factor for it.
But still better than nothing.
Yes.
Okay,
From my side of view, and from the music perspective of the simulation, actually we can see simulation in new music nowadays, even in the pop music, because we use VST, right? We use virtual instrument that simulate how the sound works in reality, and sometimes it can go farther than that. It can go beyond the physical boundaries of the instrument. I think that is one thing that keep pushing music forward to giving the composer and the musician tools to explore new concepts and ideas. Yeah, I think that's very useful for us artists. Yeah. Yeah.
How about you two? The rest of the engineering team.
Okay. In my opinion, we have simulation technology many in daily life. Yeah. The game, you can play the game with VR. That simulate.
Oh, okay, okay.
That is simulation. Yeah. You can.
I'm not familiar with computer game, but
You can drive the car by the simulation.
or the
Yeah.
flight simulation
Shan-
game, something like that.
Yes, yes.
Okay.
And when I want to make something to modeling, I can use the simulation. I can simulate it, what it is to be, and how to make it, how long to make it. Yes, it's useful. It's reduct the cost for make it. Yeah.
Exactly. Yeah.
Thank you.
Okay, Karl, do you have anything to add to this, or any suggestion, any reflection?
I think this was very good descriptions from different applications and examples. And to me, because we are in a musical or new music and art symposium, the remark by Thanapat, I think should lead us further, that he simulate the response of a concert hall, of a reverberation,
Right, so you're
and
talking about
also
the convolution reverb.
can go beyond the physical limits of a musical instruments. And that is interesting for modern time composers. And so there is a link between, say, the existing instrument that they can reproduce or represent to some extent, and need not be perfect, but then they can go beyond, and there is still a link. It's to the real physical behavior, and that makes it, I think, meaningful, because music always has a link to some traditional or older or folk music or something, that it's understood as music. A certain link. It can be experimental. My thing is experimental, but there is still a violin. People see a violin.
Thank you, Karl. And I think I tried to talk to Thanapat about this earlier, and he also presents some interesting comment. He talked about of course, physical modeling, and also to use something to simulate the real world. But not only that, but he can create some program that morph between the two real thing and the distance between the real thing, somewhere in the middle, maybe the most important part to me, because that is not real anymore, but it's like, right?
Yeah. So as I come up with recent work, I experiment with harmonic series shifting on digital musical instrument. So we can have one fundamental tone, right, sine tone, right, and we can have the multiple of sine tone in various way, in various decay and attack. So it can simulate any physical sound that it can appear. But more than that, we can program the computer to translate or transform from one sound to another one. Okay, you get it, right? So we can, it's like using the audio mixer, but with harmonics and the frequency of them and the decay and the release of them. So we can morph from one sound like oboe into tuba. I think it's pretty interesting, and it's really expand the creative process of the composer very well. Yeah.
I would have called that, I love this idea. It starts from kind of analysis.
Yeah.
You would not
For,
even
yeah,
call that, you would not call that simulation, but it's the simulation, but you start
Yeah.
from kind of analysis. You
Yeah,
have
yeah.
a thinking and perception of how music or sound of your bells. I did listen, I enjoyed in Facebook your bells. You have an understanding, and then you make a setup of your sine waves.
Yeah.
And then you start, and I call that in Germany parametrisieren.
Yeah,
So you
yeah.
have parameters,
Yeah.
and you do variations of that parameters, and you find something. And in my program, I call it like a sweet spot or something.
Yeah, yeah, yeah.
And this is how we work. And you can easily call that simulation, but in music, it's not. I think it's not.
That
It's
simulation.
not so common to
Yeah.
call it simulation.
In my way, yeah, in my opinion. But yeah, it's exciting to know that we can have a gap between
And-
those sounds.
And in your case, your application, I would not have a doubt that it's not the real thing, because it's something very systematic and it has a very close link to what it happens. It's what physicists do. I mean,
Yeah, yeah.
but you use your ears and your selection process and aesthetics to deal with it. So you don't do physics. You are not studying bells like so, but
Yeah.
you do music, yeah?
Yeah, yeah. From the music standpoint, I
Yes.
really enjoy that. Thank you for your input as well. Yeah. Okay, so
Maybe I think I would like to hear from the engineering team more, because all of you are not professional musicians, right? You are engineer much more than musician. But now, since you are here among all this kind of so-called contemporary music or music of today, which of course rely very much on the new technology, what do you have? What is your idea about this? I mean, you have talked about the simulation in terms of engineering point of view, but what about in terms of music? How do you think that the simulation technique can help musicians from engineering point of view? Always a tough question, I'm sorry.
Yeah, tough question. From my point of view, for this question, first, I'm computer engineering student, right? Computer engineering is the middle of this simulation world about physics engineer, something like this. And for you is music, right? We are the middle of everything, because today all the computer is the middle of the real world and digital. Yeah, middle between analog and digital. So, yeah, and from my point of view, one measuring topic about this, I think similar to this, yeah, is DSP. You know DSP? Yeah, is how can I say it?
Could you take the microphone now?
I try to translate what he wants to say. So DSP, like that occur in Ableton Live in all the music software, is actually rooted from the engineering side, which like a bridge between the art and science world. So yes, yeah, that's what he want to say. Is the medium of both worlds. Yeah.
I think that DSP is used to be a catchword in music tech world as well, right? I think decades back ago, we used the word DSP, and so it's kind of everybody in the new music scene used to know that term. Not much at all, but it's a catchword at that term. Now, I think looking forward into the future, though, Karl, what do you think that this kind of technology simulation can help us in the new music in the future?
I think what we have talked about so far is a DSP, meaning sound alteration or simulating the reverb of a concert hall or something, and maybe simulation the sound of a trumpet or something. This is commercial now, on commercial synthesizers, implemented to some extent. But now music making is more, it's interaction, it's depending on human response and behavior, on perception of group dynamics and so forth. And all that could be to some extent simulated. If the engineering team, the robots are not in the industry, the robots are not a replacement for humans, but it's production machine and to some extent, so to speak, intelligent. And so what is about music that you would like to simulate, to automate, to replace? So this depends on the musicians. But when I present the violin machine, only very few people say, oh, this makes the violin players jobless, because it's a complete different thing. Yeah, it makes things that the violin player would not dare to do, or so. So we could ask the composers what you want to simulate, what you want to then extend after having understood the real thing, so to speak, and then from there extend.
I think to me, one question that I would very much to know the answer before I finish my composition is that sometimes we tend to write something in terms of algorithmic, right? To the point that we state condition, maybe many conditions. And it's kind of hard to predict whether this condition will work together well or not. Will it create some feedback loop or not? Let's just say we have the analog, completely analog example, right? Suppose I write a rule for human behavior. For example, I will ask the piano player to press a key as soft as possible, but still produce a sound. And sometimes in the real performance, sometimes the pianist made a mistake. He played too soft so that there will be no sound produced. So this will be like two conditions. And from these two conditions, they will lead to a different next step, step B. And in step B, we can create more conditions, which lead to more and more conditions. It sounds simple enough in theory to me, but in practice, it's hard to predict the outcome or the aesthetic sound at the end. It will be tough to predict that. So I would like to know whether this problem can be solved by a simulation.
So I think for the simulation is actually, it depends on the input that we gave it, and the other factors. One of the inconsistent factors is human, because human is uncertain in some instance. So we can simulate things on computer, but for more dynamic ways, we sometimes may have to look at the real thing as well. Yeah, to give the best of both for like the raw and algorithmic things and the ever-changing dynamic system of human and living things. Yeah, and one concept that I very interested in simulation is like automata. Yeah, so like self-processing or self-evolving from like it can start from pretty simple algorithm, like if you know the convey games of life, you know that it's like how you know the convey game of life. It's like a computer program that simulates how one structure can grow and die. It's like population simulation in a way.
That brings me to sorry to interfere. Bring another term that I wanted to mention. That is gamification.
Yeah, gamification. Yeah, that's the word. Yeah, so it's like one in one sense is make the system easy for the audience to see and the audience to understand how simulation work, how it can grow over time, and how it can die out. Yeah, I think, yeah, that's one example for me. Yeah.
ทางทีม engineering ครับ we're talking about some algorithmic thinking pattern in writing music. Is there anything that you would like to add and to help speeding this process? Sometimes if we give and provide rule for composition for musician to play, if you confront this situation, do this. If not, do this.
Okay.
Condition go on and on.
Yeah, for this problem, I think I advise to use some technology that called artificial intelligence. You know this AI. Yeah, for in this measure we have one problem we call reinforcement. You know, reinforcement. Yeah, algorithm there. It is simulation to a small world, and we add the agent to this world. And then, yeah, we give the rule for him. Yeah. Your problem that you say about you give a rule for piano player, yeah, to put soft red to get the sound.
To
yeah.
play as soft as he can. Yeah,
Yeah.
let's say that is a rule.
Yeah, we can give the rule to this agent to tell him that you put, if you can use any
Actor.
you can use
actor.
any Newton, to put to get a sound, and we will give you a reward or punishment. Yeah, and we give this simulation speed 10,000 times to real world, something like this. Yeah, if he plays and don't have sound, we punish, and if he used too many force, we also punish, but we also give a reward if he gets sound, and we repeatedly do this. Let him work on his piano until one day he will learn how to put the software to get sound.
I see. Yeah. Right, and Thanapat just said this is learning theory, right? And just to be clear, right?
Is it called machine learning? Is that?
Yeah.
The same thing?
Reinforcement is a subset of reinforcement. Pardon. Reinforcement is subset of machine learning. Yeah.
Okay. Just to be clear, because I'm the low tech here, we are talking about technology nowadays, right? At present day, which we can do that now already, right? We are using it now, right?
Yeah.
Okay.
So like okay, so in the future, okay, like look as far future, like so Karl, do you have any like prediction or any like any dreams about future technologies?
First, I have a doubt. It's maybe a Western standpoint. Do we want that? I mean, is the essence of music? Is the essence really to press the key at the right pressure? Because that can be automated, as we have heard. It can be even automated without machine learning. I mean, in quality assurance principles of statistical process control or so, they learned in 1950 or so, the Japanese learned that, not the German, the Japanese, how to optimize a process, a technical process to limit the variation. That's what you are asking for, yeah? Variation. So it's very, very so. But is that the main essence in music making, or and so you would try to refine that, or do we looking for something else?
So I think now we can,
so because there are people that refuse to use of technology in music, yeah.
Yeah.
Not me, not me.
So I think we can get a little bit into human and technology a little bit in the future, because there is like the balancing in nowadays, that we have to balance our social life in online with the real thing, the digital thing and real thing. I think is in my opinion is up to the use and the purpose of each simulation or each process, what we want from it, what we want to see the possibility of it. I think that's one key thing about simulation for me, about the purpose of it. Yeah, why we use it, why we don't use it. Yeah.
And I think I agree with that, Carl. To me, it's not about it's not about the how to be as precise as you can. To me,
Sorry.
because to me, I think we love impreciseness. That would be the charm of music. I think the way to use it would be, if you go back to the imaginary pianist who has played that soft note for many times now. I think the charm is that we will never know whether he will play and we will hear the note or not. Sometimes he'll play too soft so that there will be no music, no sound at all. And sometimes he'll play loud enough so that there'll be a sound. But I think the interesting thing is that coming from that, after that sound happened or not happened at all, there will be two different conditions. So the music evolves in a different way. Suppose there will be sound, then you go to route A, and then you confront another condition, and there'll be another 2 or 3 conditions. Suppose there's no sound at all, you go to route B, and there'll be a different condition again, and this creates kind of interlocking system of composition.
Yeah.
Right. Which is hard to predict. To me, as a composer, it will be tough for me to predict that. But I just wonder, maybe the machine learning can help provide some example of this quickly, instead of bring my score to the ensemble and then frustrate them with they have to play so many times, and sometimes they play the wrong condition like that. So whether that will help or not, I'm not sure though.
Okay. Yeah.
Go back to the topic that
Right.
simulation in future.
In the future, Carl, let me
for
go back to
music.
the engineering point of view.
Yeah,
what they think in the future. Yeah.
Okay. I think imagine this. Okay. In the future, if you want to watch some musician, the popular musician, to play music, you have to go to watch him. You stay here and you have a robot that play the music, and the robot the musician play another place, play the music another place, and send the signal to the robot, and I stay here with the robot, and I can hear what he play. Yeah. Do you get it? Yeah.
So it's like simultaneous technology, like in the
Yes.
same time, same
Yes.
like
Yes.
yeah. So real time data transferring.
Yeah.
Okay.
Something like that.
Okay.
Yeah. I think
Okay.
it is a view. Is interesting things.
Mm. Okay.
Thank you.
I have an idea about how technology, how simulate will help the musician. Like I don't know it's right or wrong in music way. If you want to have a band will play like and in my way the simulator will help us predict. I saw that I see that it can be like predict the condition like จุดผิดพลาดในการเล่น
So like it can simulate the failure as well as the success of human. So that is like the future that she
Exactly,
yeah.
yeah.
And if the musician see the overview, you see the band and you see the overview of the band of the song. So you will know that, oh, this part you will have to do like this. It will make perfect, something like this. This my idea is just imagine.
Okay, it looks a bit like a scary future to me, though. But I can see that it might benefit many people, right? To me, it's kind of wow. We are in the far future at that point, to me, right? But would you think that will happen in the next few years?
I'm not sure, but in my field, everybody have many people have many engineers have ความสามารถ potential to do this, and I think many inventor think that's
Oh, so
already
will come
because I
will come
can
sooner
think.
than later. You say that, right? Which is quite scary to me because of this, Karl. Suppose we input enough information, right? Suppose the four of us are in the band, and we input Thanapat's ability as a musician here, and we input the three engineer ability in music here, and they can predict that every time that we have rehearsal, this guy will make a mistake. Let's say that, and then so I'll know in advance that this should not be the member of our band anymore before he become a real member of my band.
But
Oh.
I want to.
But that means then the robots need personality.
Right.
But I have I think another view that if you practice the guys to be better, it will make us be better than get out something
True.
like
I
that.
agree. Yes, I agree. And Thanapat, I think we talked earlier about some kind of almost like predicting the future in a way, right? Which is to me again another scary concept. Could you
Social
could you
simulation.
elaborate on that?
So, in my thinking, so we can harness the power of of the simulation to in some way predict how human works in a community. That is like a social science thing. So actually we can merely see the future, what is gonna be, or the possibility of how humanity is going to be in terms of the economics, environment, politics, something like that. We can simulate in that. I believe that some scientists already do that nowadays. So, but it's not like so public onto the onto society yet.
Okay.
Yeah.
Karl, do you read science fiction?
No.
Okay. I mentioned just because you don't look like the guy who reads science fiction. I just mentioned because there'll be
But
another. Go ahead, please.
So the digital representation of things, let's say robots or music or so, makes it in a way arbitrary. So it can be transferred via internet everywhere in the world at almost even without delay. And that makes it's losing its value. Yeah, it's losing the authenticity, and so it's ubiquitous and not special, not of special. It's accessible anytime and everywhere, and I tell you, my music machine, yeah, it may be crazy, but the value of this kind of artifacts is boosting up because of the digital world. It's making things so easy accessible. So an old violin or any old instrument or so physical, the value goes up and boosts up because of the existence of simulation.
That is one very interesting point. The value of the physical versus the digital data, the programs that we use. How it's different from having the real DX7 and the simulate one. I think that some music snob, some music enthusiasts will know in heart that they really want the real thing, the real scenes that they dreams, not the simulate one in their computers, right? That is one point that reflect on the music production point. Yeah. Right.
But you're using the DX7 as an example, which is a simulation in itself.
Digital.
Yeah.
So use that as the real thing.
Let's say Prophet 5 then.
Yeah. More analog. Yeah. Okay. Like a MOOC one. Yeah. Okay. I think so. We have more time, or we.
Do we still have time?
So how many minutes right now? Okay. 45? Okay. So we have like around 5 minutes left. So can we wrap up? Okay.
So I think that, Karl, Karl, would you like to have a few words for the wrap up first before I go to the
Before the wrap up, I want to see more use of computer technology in musicology, because I think I first want to understand music before I automate it. So this is a very conservative statement, but the musicologists are just about to adopt computer. So that was psychoacoustic. That was from the engineering side. They studied the perception and music and psychology of music, but that was not supported by computer science. But now I want to see musicology using simulation.
Yes, thank you, Karl. So let me turn to the engineering team then. Is there any last word that you would like to leave for the audience to understand about technological simulation?
I think that I willฝาก that technology, that's the thing that human make it. So the human should is to use or replace the own thing. So the develop of technology is still good, not scared. That is in the last, the human decide to use it. It won't replace the job or many jobs, so don't scare it.
I want to see some technology in future. I like to travel, yeah, and I use the Google Earth, and I can go everywhere in this world. I can go to Angel in Canada, and I can see around my, yeah. In the future, I want to
perceive more accurate view.
yeah, perceive
of
more
simulation.
Yes, more simulation. You can smell something, food. Yeah, smell the fall, HLR fall. I can smell it. Yeah, something like that. Thank you.
Yeah, I'm agree with Kaimuk. Don't scary the technology. Yeah.
Don't be scared of technology.
ครับ
So, as one of the enthusiasts myself, I want to believe that technology depends on the purpose of the use. what the purpose that we give to the simulation or what we want is the most important thing for me. So do we really need simulation to actually enjoy the real thing? Or we better go to see the real thing? That is one question that occurs in entertainment, in music, in theater, in every field, that do we need to stay apart from each other instead of, let's say if we go through this novel coronavirus and somehow humans want to get back to each other, humans want to reconnect, do we need to this kind of thing anymore, or we need to see each other, right, Karl? So
Right.
yeah, so it's much better that us human, a living being, stay with each other and being a community. So that's one of the few things that simulation cannot replace the human bond. So
Thank you,
yeah.
Thanapat. I think it's always feel funny to me when people go to a concert and then look at their cell phone instead of look at the real thing in front of them, right? Okay, Karl, you have the last word here. Go ahead.
Oh, thank you. This was a very competent and relaxed. This I enjoyed the relaxed discussion. 7 o'clock in the morning in Germany.
Oh, really? For
And
you?
and I hope to in person come to Thailand someday. And thank you very much for selecting my work and having me in your symposium.
Hey, Karl, this is Piwat. We are definitely having you once we can travel, so you have my promise.
Okay,
Thank
now
you.
he go. So yeah, thank you everyone, Jiradej. So thank you everyone for coming. This is the last day of Thailand New Music and Art Symposium, and yeah, we have two more performance today at 3 p.m. in Thailand and 5 p.m. in Thailand. So keep a look on that. We will live on YouTube as well as physical here.
Thank you, everyone.
Okay.
Hey, bye bye.
Thank you.
Bye bye. Bye bye.
Bye.
Bye bye.